All right, so today we're going to talk about determining if we can make a relation a function. So there are two ways. First way is the vertical line test. So can you draw a vertical line that only touches the graph at one point? Okay, so this first picture is an example of yes. This one would pass the vertical line test. Okay, I could even draw another vertical line over here. Okay, it only touches my graph once though. Okay, second picture, so this would be a yes. Second picture is not a function, okay, because my vertical line touches here and here. Okay, so that makes it not a function. The second way that you can tell is if you look at your x values. Okay, so we are looking for a repeated x value. Okay, so we're not even really worried about the y values at all. Okay, so I'm going to underline my x values in all of these points over here. So I've got -1, -3, 0, 3, and 4. None of those repeat, so this would be a function. Okay, looking at the second example, I've got -2, 3, -2, 4, and -2. Okay, the fact that the -2 repeats makes it not a function. Okay, now we'll go back to this first one. The y values here repeat, but y values are okay. We just don't want x values to repeat. Okay. So on the next page, I want you to take a few minutes and I want you to determine if the graphs are functions and then why or why not. Okay. Guys, your why or why not is all based off that vertical line test. Do they pass the vertical line test? So I'm going to start with the first one, or sorry, the second graph up here. So if I were to draw a vertical line, okay, I only touch my graph once. Okay. Again, it doesn't matter where you draw your vertical line. Okay. I always look at it as sometimes you want to look to make sure there are certain places that may or may not. Okay. So this one is a function. First picture here, well, if I draw a vertical line there, it would work. But we always want to pick the parts of the graph that don't look like they would work. Like this one. Okay, I actually touched 1, 2, 3 different times for that one. Okay, so that one would not be a function. And again, if it asks you why or why not, you can say it passes the vertical line test, it doesn't pass the vertical line test. So the next one, we're going to use that x value way. Okay. Again, not looking at the y values. The y values can repeat. We're not worried about those. We are only worried about the x values. Okay. And then your why or why not here for your answer could be it has repeated x values. It doesn't have repeated x values. They're very short, simple. Why or why not? I'm not asking you to write me a paragraph for them. Okay, so if we start with this upper left one here, looking at my x values, 1, 2, 3, 4, 5, and 6. None of them repeat, so this would be a function. Going down to the middle one here, 0, 1, 2, 3, 3, 5. The 3's repeat. That one is not a function. 0, 1, 2, 3, 4, 5. That one would be a function. Look over here, guys. Okay, my y values repeat, but again, we're not worried about y values right now. We are only worried about the x values. All right, next thing we're going to talk about, domain and range. Okay, so hopefully, again, review for you. Domain is your input values. Okay, this is also called your independent variable. The way I kind of remember it is they both have the prefix in. Normally, we associate domain with our x values. Okay. So then range is output values, dependent variable, and usually what we call our y values. So what I want you to do And what we're going to do is we're going to identify the domain and range of the following. Okay, guys, domain and range only work if it's a function though. Okay, so why we did the last two slides is here. Okay, we always want to make sure it's a function first. Okay, so now we've got new words to go with our x values and our y values. So this first one, this is called a mapping. So it's just another way to show input and output values, just like a table or a series of points or a graph. Okay, so mapping, input, remember, that's my x value, that's my y value. So as I look at this, okay, when you're looking at a mapping, you want to look for more than one arrow out of a number. Okay, so 2 only has one arrow, 4 only has one arrow, 6 only has one arrow, and 8 only has one arrow. The 8 got down really far there. Okay, so each one of these input values only has one arrow. So this would be a yes, it is a function. So then my domain would be 2, 4, 6, and 8. So it's all the values in that input circle. Range then would be 0, 3, and 5. Okay, don't worry about the curly brackets. If you can't write them, just write parentheses. Okay, either way is fine. Okay, so there's your domain and range for that one. Moving on to a table. So another way just to show you a relation. Okay, we're only looking at input values. Okay, so I got 1, 2, 2, and 4. Okay, this is not a function. Okay, so if it's not a function, you do not have to worry about domain and range. Okay, because domain and range only work if you have a function. So this will lead into what we're going to do tomorrow. Okay, but we're going to make a table of the function y equals x plus 4 when the domain, so there's a vocab word, is 0, 2, 3, 6, and 7. So my 0, 2, 3, 6, and 7 are going to go in for my domain or x values. So 0, 2, 3, 6, 7. Okay, those are also my input values. So I'm going to plug them in for my x one at a time. Okay, so I'm going to have y equals 0 plus 4. So you get y equals 4. Okay, so when x is 0, y is 4. Then you're going to repeat the same thing. Y equals 2 plus 4. Y equals 6. Y equals 3 plus 4. So you get 7. And then 6 plus 4, and you have 7 plus 4. So 6 plus 4 is 10. 7 plus 4 is 11. Okay, so you filled in your table. The last thing we're going to do is we're going to be given a table, and we are going to write that rule up there. Okay, so here is our table, and it says write an equation or a rule. Okay, you'll hear me use those words interchangeably. Okay, so what you want to look at is kind of the pattern. I always start with the first one. How do I get from 1 to 0? Well, first thing that pops into my head, subtract 1. Okay, so subtract 1. Does that work for 2 to 1? Or 7 to 6? Or 9 to 8? Am I subtracting 1 each time? Okay, so then if I'm going to write my rule, it's y equals my x value and then minus 1 in this case, which is the pattern that we came up.